Now let us focus our discussion into one of the most important and quintessential microcontrollers in the IoT world, that is ESP8266. Now, as we have discussed earlier, connectivity to the internet is of high importance in the IoT world. Any microcontroller can be given this particular access with the help of Wi Fi modules such as ESP8266 itself. But then, why are we focusing on ESP8266 especially? The focus on ESP8266 is quite important for the reason that it in itself is a microcontroller which has already integrated Wi-Fi system. So you don't need to plug in an external circuitry in order to connect it to the internet. So it itself is capable of connecting to the internet, and hence it is a very important microcontroller that we have to look at. Let us try to look into it. Understanding this microcontroller and its functioning shall give us a very good basis to start off our IoT journey. The complete and self-sustained Wi-Fi networking solution allows it to either host the application or to offload all Wi-Fi networking functions from one application processor to the other. ESP8266 integrate also has integrated an improved cache in order to improve the performance of the system in such applications and to minimize the memory requirements. ESP8266 onboard processing and storage capabilities allow it to be integrated with the sensors and other application specific devices through GPIOs, that is general purpose input output pins, about which we'll talk in the pin out discussion, with minimal development upfront and minimal loading during runtime. With its high degree of on chip integration, which includes antenna switch balloon, power management converters, it requires minimal external circuitry, and the entire solution, including front end module, is designed to occupy the minimal PCB area. ESP8266 has been designed for mobile wearable electronics and Internet of Things applications with the aim of achieving the lowest power consumption with a combination of several proprietary techniques. The power saving architecture operates in three modes: active mode, sleep mode, and deep sleep mode. Now, what are a few important specifications that we need to know about ESP8266? We need to know the following specifications. Number one, it runs on a 3.3 volt supply voltage. The current consumption depends on the different applications, and basically, the details of this consumption can be read from the data sheet, the link for which will be shared later on. Now, this is what we have seen about the technical description of ESP8266, and it might not be possible for a person to understand everything what it does just based on this particular definition. So we'll definitely delve deeper and explain each concept, but let's first look into the pinout. So the pinout of ESP8266 is as shown on your screen. What are the different components of the pinout? Number one, general purpose input output pins. Now they are used for connecting various sensors and modules to the ESP board. As you can see, there are 16 GPIO pins which have been numbered on the right hand side of the board, and there are 14 on the right hand side, I beg your pardon, and 2 on the left hand side. Now care must be taken that the numbering and the naming of these pins is not as what it is displayed on the actual physical board. The D0 is actually the GPIO pin number 16, and it is also used for user and wake purposes. And hence, this particular figure, which we have displayed over here, is of quite importance because the numbering is not as it is shown on the board. Second, the ground pin. As the name suggests, ground pin is basically the pin which connects all the grounds to the common ground. An electrical circuitry is incomplete without the inclusion of a power pin and a ground pin. So this is the particular ground pin which we are talking about. And the third important kind of a pin out is the reset button. Now the reset button helps us to reset the ESP8266 board. Now why is resetting important? We'll probably discuss a little bit more on this in the upcoming slides or in the project modules. But just to give you a brief introduction, let's say if we have uploaded a particular code on this board to perform a particular task, but for some reason the cache has to be cleared in order to read the code properly. So this reset button helps us to do that without erasing the code from its memory. And the last, the ESP8266 only supports analog reading in one GPIO. That GPIO is called ADC0, and it is usually marked on the silk screen as A0. What do we mean by the silk screen? The board itself. The zigzag figure that you can see on the top of the board is nothing but the antenna, with the help of which it connects to the internet, transmits and receives the information. Now, the fourth point that I've mentioned over here says that analog reading. Now, what is this analog reading? What is its counterpart? The counterpart of an analog reading is digital reading. And what is the exact difference between both of them? We'll talk about it more in the upcoming slides and also in the project modules. So overall, this is how an ESP8266 looks like. And majorly, we'll be dealing with the GPIO pins, that is the general purpose input output pins. With the help of these pins, we'll be able to carry out different functions with the help of different sensors and modules. Like, to give you a crude example, with the help of one GPIO pin, we can take information from a particular sensor, and with the help of another GPIO pin, based on the information we have obtained and the processing that has been done on that information, an output command can be sent from a different GPIO pin to a particular to some other module or some other application. So, in a nutshell, this board is basically taking in an input from its external environment, processing it based on the code that we upload on it, and executing an output through another GPIO pin.